I'm like immune to all the bad parts about Apocalyptica. For me, it's all just details. Think about what I do for a living, children. I find beautiful, promising, hopeful, ideological young people, and I give them bad news every day. And you move on. Like next year, you'll take like basket weaving and like sex ed or something. I'll be doing this again. This is my career until the year 2037. So I think I've got some stuff to deal with about like the end of days and darkness and bad news. So I process that by reading like every book of apocalyptic fiction.
Was there's Maggie Wild?
I beg your pardon?
Maggie Wild?
Figured one. And because I'm always thinking about apocalypse, I can tell you I've thought about number 43 a great deal. Number 43 gets 2 stars. Says, what factors promise a rise in disease? Let's talk evolution for a minute. You are engaged in an arms race against all the organisms that cause disease, the bacteria, the viruses, the parasites like worms and whatever else causes disease. I don't know really, I'm not very smart. Just like cybersecurity, electronics nerds are always trying to make like a better security system, and then all of the criminal hackers in the world are trying to chip away at those defenses. We've evolved for like a gazillion years to outsmart the diseases that are trying to get at us. And we are 2 different extremes of that arms race. We have very, very, very fancy defenses. Each of us is like an impenetrable fortress. Honed by millions of years of evolution. We have layers upon layers upon layers of defense. A very significant amount of your metabolic energy goes to fighting off things from outside your body. The only advantage that they've got is numbers. They're very, very simple, but there's a whole lot of them. And you are one attempt that lasts, what, 65, 75 years? While some bacteria breed 4 times in a minute. So, you know, you're like, hey, look, I put a new password on my banking account. It's a really good password. And you're going to be with that password for, what, 70 years or something? And just like a hacker, the bacteria are like, yes, but I've got time to keep trying. Does that make sense to everybody? The funny thing is, there are many trends today in modern human society and environmental issues. There are many, many trends. If you want to give this to a meme, go sort them all out and do all that. Who's already done? There are many trends in human society and environmental issues today, which are kind of tipping the scales. The odds are improving for disease and getting worse for you and me. I mean, you all realize we're right on the knife edge of dying at all times, right? Some deadly disease probably came across your skin in the last day or 2. But that's all right. You're a pretty fancy mechanism. Problem is, I fear that the odds are tipping in the favor of disease and to disfavor us. That's what 43 is. The list of 9 reasons why we will probably lose peace. Yeah? That's number 6 or something. Let's see which one it is. I don't remember. Number 1, we're increasingly exposed to zoogenic diseases because cities are spreading into the wilderness and we eat more and more bush meat. These are 2 trends that make us more susceptible to zoogenic disease.
What do you mean by bush meat?
Eating food from the wild. Like among upper middle class food snobs like me, that's like double righteous Patagonia catalog. Eating wild foods, like dang, couch potatoes, admire that. But globally, just out of plain old desperation, people move to the city, can't find food, and they go walk off into the bushes and eat the raccoon or the chipmunk or the monkey or the owl or whatever. And we're kind of brushing up against zoogenic diseases, more and more humans against more and more zoogenic diseases every day. It's a trend that's growing because cities are spreading into the wilderness and because more and more people are resorting to bush meat, which were previously not consumed parts of their wildlife. Number 2. More and more we're living in cities, which means we're rubbing up against sewage and trash and livestock, too. Cities are really changing. And humans are getting more and more time in those. Which means we're more and more rubbing up against the stuff that makes us sick, things that carry us. Number 3. Every day there's more people, which means every day there's more hosts. Does everybody understand why a hacker is happy if there are more and more passwords out there? That's right. There's a higher chance of you getting the right one. If there's more lottery tickets. I mean, if there's more winning lottery, bigger, more lotto numbers, you've got more chance of winning. So number 3 is population is growing, so there's more possible hosts. Bacteria has better chances of winning against one of them when there's more of them. I hope it's not distracting. I'm looking for this fascinating book called The Evolution of Disease. I've got the evolution of a whole bunch of stuff, but that's a really interesting book. Number 4, we've got excellent medicines. They kill almost everything. Erlia says, is one of the reasons that we're losing because of all the chemicals and antibiotics and stuff, and I say basically yes. Because our best attempt has gotten really good. Nowadays, we've got antibiotics that kill 99.49% of bacteria. If you're good at math, does everybody understand what that leaves? The 0.301 that it couldn't kill, right? Are those going to be the weakest and least? Those will probably be the ones that we really got to worry about because they're resistant to our medication. Does that make sense to everybody? These are called superbugs. And it's a really funny, esoteric given that unless you can perfectly kill every disease germ, you are basically improving the genetics of the remaining disease germs. Does that make sense to everybody? There is no perfect medication that kills everything. So every single time we use hand sanitizer, every single time that somebody puts antibiotics into the cow, into the shrimp farm, into the little kid, into the Jose with the boob in the elbow. You gotta remember when I had my swallow, if you had a staph infection. We got to use the antibiotics, and they're really good, and they almost always kill almost all of the disease. And so just as like a funny little quirk of modern medicine, we are making better disease tests.
So it's just gonna be a never ending. Because there's really never ending point.
I think it's ending. I think you're right that it's an unbeatable thing for us, right? That we can never make a perfectly 100.0% deadly medication. And so that problem exists forever, that we need to keep evolving our medicine tool to stay ahead of the superbugs. But there are two alternatives. One is that arms race goes on forever. The other one that we lose. Because it's not likely that we can win that one. You know what I'm saying? Yeah.
So, what you're saying is like the bacteria that's being killed off by antibiotics, the ones that's gone, the other bacteria is better off.
It's like selective breeding. Yeah, it's like selective breeding. So when I took my first round of antibiotics, in my body, a ton of bacteria died. But apparently the one that had infected my whatever lymph node in my elbow, that bacteria was immune to the first round of antibiotics that I took. So now it's living inside of a Jose with much less other bacteria. And so I've kind of cleared the deck of all the other bacteria that might have been competing with that one Staphylococcus strain. And then that one strain of bacteria was like, yes, nobody else around. You know, in this case we won, it's okay, I found another antibiotic that can do it. But that means one more time I've exposed bacteria to this one strong antibiotic. So sooner or later, bacteria will spread that's also immune to the one that worked. And then we'll have one more superbug. Yeah?
So if we just stop advancing our medicine, then
We just lose sooner.
we will. Because
Because then you're just not using medicine? Like, what's your alternative?
I mean, no, just use the same. There's, yeah, at some point, one will evolve.
Right. So it's the best we can do, but it's not a perfect solution. Antibiotics are the best we've got. And by the way, I say antibiotic, that's specific to bacteria. Remember that there are other medications specific to other types of germs. Is that clear for everybody? Antibiotics don't kill virus, for example. There are antiviral medications for that. Number 5. There was a time not so long ago when it was very difficult to travel. International travel used to be a rare and special luxury. Very few people, I mean, think about the days of the Titanic. I mean, think about 100 years before the Titanic. If you wanted to go from the East Coast to the West Coast, it was going to be fraught with peril, hard on the body, not likely to work out, and nobody went from the East Coast to the West Coast. One of my homies didn't even have to take time off work. He went to go see a Dinosaur Jr. show last night in New York. He got to work early in Los Angeles, got off at 3, got to the airport by 3:15, was at the show by 9 p.m., saw the show, had some drinks with a homie, flew a red eye, showed up at work today, no problem. Travel has become very easy. I'll give you an example. How many of you have traveled internationally at least once in your lifetime? Look around. That's all but 2 people, maybe? How many of you have traveled internationally more than 4 times? Damn. So let's try this. I think this illustrates my point. The ease of travel increases what's called the vector effect. Raise your hand if you have been to South or Mesoamerica in your lifetime. So it's safe to assume that with 7 or 8 of us having traveled to South and Mesoamerica, we probably have brought back some South or Mesoamerican germs to this population of humans, of the 20 odd of us here. How many of you have been to Europe sometime in your lifetime? Well then. What about the South Pacific, including Australia? Oceania? Well, that's like 7 of us. So we've got germs from Fiji, New Zealand maybe? Okay, Australia maybe? Yeah, we've got germs from Europe. We've got germs from South America here, Central America here. What about Asia? Not very likely, but alright, yeah! Asia germs. And this is the one that you know. You're white, so. The dark continent. Africa? Don't feel bad. Oh yeah? Okay. You went to Africa? Okay, yeah, that counts. That counts. That counts. Who has? Oh, really? Yeah. We don't often travel to Africa, but usually most of my classrooms represent every major landmass on Earth. With the ease of international travel, we serve as vectors to help diseases spread. The same way that invasive species are basically combining all of the world's ecology into one mega ecosystem, we are also dispersing all of the planet's germs. And remember that everywhere you've gone, you spread your American germs too. You might remember that there was a time when previous North Americans were sickened en masse by the arrival of Europeans to this landmass. Have you heard that? That many of our European diseases caused rampant pestilence among people who lived here before. There's no place left where the germs aren't all blended. And it's becoming much easier to fly internationally. Every year it gets easier. As a matter of fact, if I'm not mistaken, the largest order of passenger airplanes was made in 2015 by an Indian airline. They ordered something like, somebody should Google this number, like 300 big, like, mega passenger planes from Airbus or Boeing or something. It was the largest single order for airplanes ever. That was made this year. You know, international travel is becoming really, really accessible. Anybody ever played a video game called Plague? So you know what I'm talking about. How many of you remember that Ebola scare in many parts of Africa, Central Africa? And do you guys remember how like everybody wanted to close all the airports and close all the borders? And all the crazy gonzos like wanted to build a bigger fence between the US and Mexico, like keep out the Ebola from Mexico? Yeah.
Didn't you get 250 Airbus?
Oh wow, tell me that again please.
250.
250 Airbus what? A320. A 320 holds 320 passengers?
No, this more. So we got the other 4,000
Capacity to carry 4,000 people.
for all two.
Yeah. So, wait, 20 airplanes each? Those are tiny.
Yeah.
Oh, cool. Anyway, remember that thing about the Ebola where everybody wanted to close all the airports and keep people from traveling because they're all afraid of this vector effect. Imagine what would happen if Ebola had broken out in Los Angeles. Like the percentage of people who fly out of LA. That's a busy airport in a busy city with busy roadways, interconnecting many other nearby populations. I mean, we just barely missed the bullet on that. This is exactly the kind of rise in variables which I think is tipping the scales. Number 6.
No relations.
Number 6. Have you noticed that the world hasn't figured out how to respond to the Syrian refugee crisis? Is this something that you all talk about in your other classes? Does this come up in school life? In your personal life? Have you heard about this place called Syria? So, in the last couple of years, warfare in Syria has displaced millions of people. We believe that climate change will force far greater numbers to migrate on a constant basis in the next decades. So the same way that we haven't figured out what to do with Syrian refugees, we're going to have to figure out what to do with global climate refugees. In other words, humans are about to scatter like roaches. There will be more human migration in the next decade than there has been in the history of humanity. What's that? Actually, due to climate change. It's called climate refugeeism.
Where is this happening now?
Well, I'm trying to remember if it was the next decade, like starting 2015 or starting 2020 and 2030. I may have misquoted that study, but it might be 2020 to 2030. We'll see more human migration of all the history of humanity getting up to that point. Basically, people who like too hot, too cold, too wet, too dry, not enough food, more economic opportunity somewhere else because not food's growing over there. Many people have tied the Syrian instability to climate change as an example. Syria's had a lot of droughts, but this recent one was really, really bad. Number 7. This is a numerical issue that is probably inherent in some of the other study goals. But keep in mind that in your lifetime, you can expect as many as 1 million generations of bacteria, maybe 3 million generations of some bacteria that don't necessarily cause disease. In other words, you've had the same password since you were born and you're going to keep that password until you die. And hackers are using like a random password generator upward of 1 million times in your lifetime. Mathematically, you know the odds aren't that good for you. And if there's more passwords out there that they can try, they've got better chances of winning. This is the mathematic downside to having population growth for us, is the generation imbalance between humans and bacteria. Yeah. Yeah, so then the question is, how bad are the diseases, right? Like some diseases just kill people before the disease can spread. But don't forget that the other variable is how densely populated are those people. Ebola has been around, we think, for a very long time. But back in the day, when Ebola struck, the village would die and nobody would hear about it. And it wouldn't spread anywhere because people weren't moving much and there wasn't a high density of people. So a village of 12 people, they all go belly up and nobody hears about it because there isn't like people traveling to tell you, hey, that village over there just died. Now that we've got more movement, the Ebola can hop to a new village before all the hosts have died, right? Ebola is a classic example of this. And if you can get that Ebola into a crowded urban center, then all of a sudden you're broadcasting a disease that will have very high mortality, but in much bigger groups of people. Ebola is a perfect example. That's why I'm so excited that the movie this week is Contagion. Anybody seen this? It's like a Hollywood film with Gwyneth Paltrow and probably Morgan Freeman. It's like a really, really, really good movie. And anyway, it's just like a Hollywood film. And so I'll recommend that you all watch it Wednesday and Thursday. Next, number 8. We are now closer. We are more crowded. And that number is only going to grow because we are urbanizing. You're around more people, more closely, and they are more different than ever before. By the way, that's also the same for the victims that you visit when you travel. You're part of that same equation that you are taking your stuff to other people who are more crowded than. And finally, number 9, I'm sorry I have to warn you, you should write it down that this is possibly pseudoscience. There's a lot of rumblings about this. I'm not convinced that this is clinically sound. But a lot of people argue, based on evidence, but I'm not convinced it's conclusive, that on average, humans are basically sicker than we were before. Maybe it's our diet, maybe it's all the chemistry, maybe it's our exposure to toxins, maybe it's a change in radiation exposures, maybe it's a combination of factors, maybe it's stress levels. But a lot of people have argued from different angles that humans are essentially getting sicker. If you think about it, most of the diseases we hear about often are on the rise. Individual germ diseases are going down, like we're now controlling smallpox better. But you realize that cancer rates keep going up, and autism diagnoses keep growing up, and allergies keep going up. It could be something about how we diagnose, or it could just be that we are inherently getting sicker. And I have a theory. This is not science, this is Jose. You probably don't have to write this down, because it'll never be right on an AP test, because I'm making it up. But my theory is, our bodies are too simple for our world. We're fish out of water. We were built for a previous time, when our bodies wouldn't be exposed to very much. In the environment where we evolved, we barely ever saw other people. Think about it. In the environment where you evolved, you traveled in a group of 17. You might see 2,000 humans in your life. Today, you're going to swap germs with more than 2,000 humans, but that's how many are at the high school. Then if you take Amtrak to the train station, to a bus, to LAX, to go to JFK, to take the subway, to go to a hotel in Manhattan, you might swap germs with like 500,000 humans in one day. Our bodies, I think, can't handle all this stuff. We had a diet of a few ingredients. Maximum in our lifetime, 120 to 150 items enter our digestive system. Today, you might get more than those ingredients in a single packaged food. And a lot of those haven't existed in our evolutionary past. They're man-made. Think of all the pharmaceuticals that get into you, either recreational or prescribed. Think of all the strange chemicals you put on your body and on your clothes and in your environment, the fragrances and oils and perfumes and stuff. The metaphor I keep coming up with is the TSA system. You know the people who screen you before you get into a plane? Your body has an immune system to like keep things from getting into your body, like a TSA agent blocking traffic from getting in the plane. And I imagine that we've got this like really simple defense system, like some high school dropout holding like a battery wand that's out of batteries and a dorky hat, trying to stop like millions of people rushing onto the plane. You just can't depend on that to keep you safe. This is my Jose shooting from the hip science about how I feel that overall we're just overwhelming our evolutionary defenses. We're not really built for this amount of stuff trying to get us. In other words, apocalypse by disease. It's good, right? Is that compelling at all? Doesn't it kind of add up? I find it super gnarly. Alright. Rather than rush into other study goals, I'm gonna leave the rest for Friday. And I'm gonna offer, we can stop the video here because I'm done today.